Now, I know many of you are struggling maybe a little bit with this notion of independent versus dependent sample designs. Um, you can't quite see why one is independent and one is dependent. So let's go through a few examples and try to take a guess, try to see if we can figure these things out. And remember, dependent samples are samples in which measurements are systematically related. They're somehow related to one another. Okay, either they come from the same subjects, that we call this repeated measures or within subjects designs, or it's because we've matched or paired the subjects. Okay, now the alternative to this is that subjects are not matched, subjects are not paired. There's two groups that have nothing to do with one another. We use dependent samples because it provides us very, very heavy advantages, very, very strong advantages. We can use fewer subjects or fewer participants, and we get a huge power increase. We have this carryover effect, which is a disadvantage, but when we have carryover effects, sometimes they can be mitigated, but often what happens is we wind up doing an independent sample design. That if we're concerned about carryover, we often opt for doing an independent sample. But my recommendation, and I will go to the grave saying this, is that when you're in the stages of designing an experiment, try to design it as a dependent sample. Try to see if you can use, as we say, the subject as its own control or a participant as its own control. And if you think like that, if you start to design your experiments like that, you'll be designing dependent samples and you will gain a whopper of a power advantage. Now, if you can't tell the difference between independent samples and dependent samples, we'll go through a few examples and try to see if you can. The problem is that people aren't going to tell you. I'm not going to tell you, for example, on a test or a situation, say that's an independent sample, that's a dependent sample, and so on. You're going to have to decide, and you have to decide legitimately. It is illegitimate. It is wrong. It is, against statistical law if such a thing existed. The statistical police are going to come arrest you. No, they won't. There's no such thing. If you just take an independent sample design and analyze it as a dependent sample, you are going to be committing a major problem, a major error. You're going to be wrong in doing that. So you have to decide, you have to assess the situation and decide this is an independent sample, so I do an independent sample T. This is a dependent sample design, I'm justified in doing a dependent sample T. Let's go through a few examples. Let's say a psychologist believes that environment is more important than genetics in influencing intelligence. She locates 12 pairs of identical twins that have been reared apart, one twin in each pair in an enriched environment and the other one in an impoverished one. Is this an independent sample or dependent sample? Final answer? Yes, this is a dependent sample. We have 12 pairs of identical twins. How are each one of these related? Well, they're related because they're identical twins. They're systematically related. Scores in one set are systematic. A score in one group is systematically related to a score in another group in that they're brothers or sisters. They're identical twins. A new experimental drug, ABZ, is thought to have beneficial effects on AIDS. We locate 20 AIDS patients. 10 of them get ABZ, 10 of them get placebo for 90 days, and then we measure their symptomatology after that. Is this an independent sample or dependent sample? You got your answer locked in? Final answer? This is an independent sample. All right, there's no relationship between these patients. They're not brothers, they haven't been matched, they're independent. Now, yes, they both have AIDS. All of these participants in this study have AIDS, so you could say, well, they're related because they have AIDS, but that's not the type of relationship that we're talking about. We're talking about, have they been matched? Is there something that makes them the same or similar or related? Um, in this case, there's no relationship, so this is an independent sample design. A researcher suspects that increasing the level of lighting during the winter months will increase mood. They select 36 students, test their mood, then replaces the light bulbs in the dorm from 75 watt to 100 watt for a month, and then test them each again. Is this an independent or dependent sample? Is that your final answer? Okay, good. This is a dependent sample. That is, there are 36 students and we test them under one condition, a 75-watt bulb. Then we test them under another condition, a 100-watt bulb. The scores are related because we have two scores from each subject. Okay, now this design, however, is majorly confounded. This is a bad experimental design. We've confounded this with order. That is, everybody got 75-watt first and 100-watt second. There are a lot of factors that might coincide with this. For example, if we gave people exposure to the 75-watt bulb in January and then a 100-watt bulb in March, the day might be longer. It may just be sunlight that is affecting these people's moods rather than what wattage of light bulb they were exposed to. So we're going to have to counterbalance the order in which we do this experiment. So what we do in a proper experiment this way is take 18 of these kids, expose them to 75 watt, then 100 watt, and take the remaining 18 and expose them to 100 watt and then 75 watt, and then compare 75 watt scores versus 100 watt scores. That's how we do this. Okay, so hopefully that helps with independent versus dependent sample designs. If you have any questions, drop me an email. But hopefully we'll be moving on from here. Good luck. See you later.